AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 4: Cluster Analysis. Cluster analysis is an unstructured learning data technique that groups a set of objects so that objects in the same group, or cluster, are more similar to each other than to those in other groups. Chapter 4, Section 6: K-means clustering. In this section, we'll look at k-means clustering, one of the most common and efficient clustering techniques used in data mining and machine learning. Learning outcomes. By the end of this lesson, you should be able to say what k-means clustering is and why we use it. List the basic steps of how k-means works. Explain how to choose the best number of clusters. Describe how k-means and hierarchical clustering are different. Use tools like Orange to experiment with k-means clustering. And understand how the clusters change as the algorithm runs. What is k-means clustering? K-means is an unsupervised learning method that divides unlabeled data into a fixed number of non-overlapping groups, called clusters. It works by grouping points based on distance and similarity. Unlike hierarchical clustering, k-means doesn't build a single tree structure. Instead, it focuses on finding the best cluster centers, or centroids, for a chosen number of clusters, k. Basic k-means process. The k-means process follows a simple loop. First, you choose the number of clusters, k. Then, k random centroids are placed in the data space. Each data point is assigned to the closest centroid based on distance. Next, the centroids are recalculated as the mean position of all points in their cluster. This process repeats, assigning points and updating centroids, until the centroids stop moving and the clusters stabilize. K-means in action. Let's look at an example with age and salary. At first, we see that the data might visually suggest 3 clusters. The algorithm starts by placing 3 random centroids. Each point is assigned to the nearest centroid, and then the centroids are recalculated. This continues until the centroids no longer shift position, and the clusters become stable. Summary of k-means steps. To summarize, start by choosing k. Assign each point to its nearest centroid. Recalculate the centroids. And repeat until there are no more changes in cluster assignment. At that point, the clusters are finalized. How many clusters should we use? One challenge in k-means is deciding how many clusters, or k, to use. If k is not known in advance, we can use evaluation tools like scree plots or silhouette scores. Scree plot for k. A scree plot shows how the total within cluster variation decreases as k increases. We look for an elbow point, where adding more clusters no longer improves the results much. That point usually indicates the optimal k. Silhouette scores. Another method is the silhouette score, which measures how well each point fits within its assigned cluster. The score ranges from -1 to +1. A value near 1 means the point fits well in its cluster. A value near 0 means it's on a boundary. And a negative score means it may be in the wrong cluster. By testing different values of k, we can choose the number that produces the highest average silhouette score. When to use k-means. K-means is a good choice for large datasets because it's efficient and computationally fast. It doesn't create dendrograms like hierarchical clustering does, but it produces clear cluster boundaries and can handle thousands of points effectively. In practice, many analysts use both k-means and hierarchical clustering together, using one to confirm or refine insights from the other. Remember, the book and supplemental resources are available online at Data Analytics Curriculum's website.